tutorial, I'm going to quickly go over exam number 7 review. The main objective is to help you understand the difference between distance and displacement, differences between speed and velocity. So you need to know the distance, the displacement, speed, velocity, instantaneous velocity, acceleration, and the force. So you're going to put together kinematics and dynamics by one single problem which you saw before. The one new thing we're going to add to this problem is the force. Okay, that's what we're going to add. Before you saw distance, displacement, speed, velocity, and acceleration, and instantaneous velocity. Today we're going to add the force to the to this graph. So the graph is so the object. Let's say object is mass is 10 kilogram. The object is moving. Moving where? Moving right here. For how long? Let's say object moves for 5 seconds. 1, 2, 3, 4. Object moves 5 seconds. 1, 2, 3, 4, 5 seconds. Good. The x-axis is t in seconds. The y-axis is 2, 4, 6, 8. The y-axis is displacement in meters. Okay. Now what is object doing? The object is moving. From 0 to 2 seconds, object moves with constant velocity. From 2 to 3 seconds, object is at rest. From 3 to 4 seconds, the object moves with constant positive acceleration. From 4 to 5 seconds, object moves with constant negative acceleration. And today you're going to try to understand what gives rise to acceleration, and that is force. And you're going to find force. Okay, before you find force, before you go too ambitious, let's see whether you are 100% good with kinematics, because you cannot move to dynamics unless you have good skill in kinematics. First, find the distance. To find the distance is very easy. To find the distance is, this is section A. Let's write it down. Section A, B, C, and D. So the distance is absolute value of A plus absolute value of B plus absolute value of C plus absolute value of D. So what is it? A is 4 plus B is 0 plus C is 4 plus D is -4. So the distance is 4 plus 4 plus 4. So the distance is 12 meters. Okay, that's good. Then what is the average speed? Since the speed is distance over time, or total distance over time, I should say total distance over total time, 2.4 meter per second, and that is the average speed. Average speed. All right, we're gonna find the displacement now. So to find the displacement, dA plus dB plus dC plus d, that's total displacement. The total displacement would be how much? 4 plus 0 plus 4 minus 4. So the total displacement would be 4 meters. Okay. So now let's find the average velocity. Average velocity is total displacement over time. So the total displacement is 4, the time is 5, so 0.8 meter per second. That's your average. That's your average velocity. This is your this is your displacement. This is your average speed, and this is your distance. Now let's see whether they make sense, right? Because the area under VT graph would be what? 4. And area under ST graph would be 12. And let's see whether we can prove that. So This is 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. We don't know how much it takes, but let's just put 10, positive 10 and negative 10. And this is, of course, your x and y. So this is what? Your 1, 2, 3, 4, and then 5. We don't need this, so I'm going to erase it. And this is velocity versus time. So what's going on? What is the object velocity from 0 to 2 seconds? Object velocity is 4 divided by 2 is 2 meters. Okay, 2 meters. And for 2 to 3 seconds is 0 meter per second. Okay, we are not sure what would be the velocity exactly at 3 seconds. So we're gonna just assume that velocity is something big at 3 seconds. Okay, what causes this velocity? Acceleration. What causes this acceleration? Force. How much force? We're gonna find all of this. Okay, and at location at 4 seconds the velocity is 0. At 5 seconds the velocity is equal in magnitude, opposite in direction. Okay, so what do you have now? You have this. So you have -2, -4, -6, -8, 2, 4, 6. Oops, this is 8. Okay, so I'm gonna do it again. So this is 8. It's probably gonna be 8, not sure. Okay. All right. So we have this area and this area. So what is this area? This area is A is equal to half BH, right? So what is A? A is the displacement, half BH, right? So the displacement you already know, 4 half. B is how much? 1, which is time h. So this is 8. So yeah, this is 8. We assume it correct. So this would be -8. So what we are trying to prove? We are trying to prove that this area is how much? This area plus this area plus this area is 4. That's what we're trying to prove. Okay, so from 0 to 2 seconds, how much is this? 4, because, or let's do it here. BH plus 0 plus half BH plus half BH. So B is 2, H is 2 plus 0 plus half, B is 1, H is 8 plus half, B is 1, H is -8. So 4 plus 0 plus 4 minus 4. Okay, so that is 4. Since this is VT graph, this 4 is the displacement. So we prove that. Now we're going to draw a speed versus time graph to prove that this is actually 12. Speed versus time graph, we're just going to take the absolute value. Okay, absolute value of this one is just this one. We're going to write 2 over here, 2 over here. Absolute value of this one is just this one. Absolute value of 0 is 0. Absolute value of this one is just this one. So this is 4. And this is 8. Absolute value of this one is, you're going to flip it. So this is 5. And this is still 8 because absolute value of -8 is 8. So we have area under the curve, and we're going to prove that this is actually 12. Okay, so what is it? Um, BH, which is this one, plus 0 plus BH. No, this is half BH plus half BH. So BH is 2 times 2. B is time is 4 minus 3. H is 8. 5 minus 4. So 4 plus 0 plus 4 plus 4. So it's 12. Therefore, we prove that the area of ST graph is actually 12. Good. Now we're going to find the instantaneous velocity. We found the speed. We found the average velocity. Now we're going to find the instantaneous velocity. What is the instantaneous velocity at, let's say, 4 point, I don't know, 3.5 second? To find the instantaneous velocity at 3.5 second, you can use the, well, you can do it many ways. Let's do it using this way. You can use the average velocity. So average velocity would be equal to instantaneous velocity. Instantaneous velocity, Vf plus Vi over 2. So what is Vf? 8. What is Vi? 0. Divided by 2, which is 4. Other way you can find the instantaneous velocity is y equal to mx plus b. At this point, what is the at this point, what is the value? Value is 3 comma 8. Over here, the value is 4 comma 0. All right. So the y is 8 when x is, what is x? X is 3. However, we have to find the slope. So what is the slope? Y2 minus y1, x2 minus x1. So this is your x1, y1, x2, y2. So y2 is 0 minus y1 is 8. X2 is 4 minus 3. So the slope is negative 8. The name of the slope is acceleration is negative 8. So this is negative 8 plus b. So y-intercept is 8 minus 8 is a minus 24 plus b. So y-intercept is 32. Okay, so y equal to mx plus b, right? So the y is equal to m is negative 8. Okay, x is 3.5 second. You want to find the instantaneous velocity at 3.5 second. So 3.5. And what is your y-intercept? 32. And that gives you exactly 4. Is that right? 28, yeah. Negative 28 plus 32. So that gives you 4. Why is that? Because this formula, if you discover it, that's Vf is equal to Vi plus At. Vf is what? You find at what time? 3.5. Vi is your the y-intercept 32 minus 8, 3.5. Okay, so you see the connection. Okay, good. Now, what else we need to find? We need to find the force. Before we find the force, we're gonna have to convert it to the acceleration versus time graph. But please understand that we cannot do acceleration versus time graph here. Why is that? Because the acceleration is not continuous. Acceleration versus time graph, we can draw it, but it will not make sense. Acceleration is 0 from 0 to 2 second, 0 from 2 to 3 second, and negative 8 from 3 to 5 seconds. acceleration versus time graph, the final velocity has to be area under final velocity has to be negative 8 because this is negative 8. However, in this case, this is not negative 8. Why is that? This area is not going to be negative 8. I'm not going to even calculate it. Acceleration is negative 8. This shows negative 16. So that's not correct. Why is that? Because acceleration is not continuous. From 0 to 2 second, acceleration is 0. 2 to 3 second, acceleration is 0. 3 to 5 second, acceleration is negative 8. So acceleration is not constant through 0 to 5 second. So this is not the best example to do the acceleration versus time graph, and expecting area under acceleration versus time graph would be negative 8 or final velocity. That's not going to happen. So let's see force versus time graph. This is not a best example to do the force versus time graph. Why is that? Is because again the acceleration is not constant. So but we still can see how much force acting on the object, let's say at 4.5 seconds. All right, so let's see. From here to here, acceleration is 0. Okay, 2 to 3 second, acceleration is 0. 3 to acceleration is 0, so net force is 0. Acceleration is 0, so net force is 0. So net force from here to here is, let's see how much. Net force is acceleration is negative 8. Okay, all right, so this is 3 and this is 5. So now let's see the force is ma. The force is mass is how much? 10 kilogram, and acceleration is negative 8. So the force is negative 18 Newton. All right, so the force was acting negative 80 Newton. That force rises to acceleration from 3 to 5 seconds. Negative 80 Newton behind the scene. Negative 80 Newton force causes the negative. Remember the force, if the force is to the acceleration is always at the direction of the net force. So the net force, if the net force is negative, acceleration is also negative. Net force is always at the direction of acceleration because acceleration is always at the direction of net force. All right, so the area of this one is something called impulse, which is the topic we're going to do next week. So impulse is equal to ft, and that's not going to be tomorrow. So this is something called impulse, which we're going to cover next week. But this is what I'm going to ask. What did you learn from here? You learn many things. You learn distance, you learn speed, you learn displacement, you learn average velocity, you learn instantaneous velocity, you learn how to do ST graph, you learn how to do VT graph, you learn how to do AT graph, and when AT graph final velocity is not going to be the area under AT graph, when the acceleration is not constant from beginning to end, and this is the case over here. So there is a limit to everything. So we're glad that this example show that. And of course, the force versus time graph tells you that the force causing the acceleration from 3 to 5, that acceleration causing the velocity from 3 to 5, right? And that velocity causing the displacement from 3 to 5. Okay, so the displacement came from the velocity came from the acceleration, and acceleration came from the force. Right. Okay, now quickly I'm going to go the last topic, and that's about it. Field. So what is field? Let's compare it with something you already know. Well, for example, gravity is a field force. So what do you already know? Contact force and field force. The contact force is a normal force, is an example of contact force. One is act is normal to the x-axis, 90 degrees with respect to x-axis. Friction. is parallel with respect to x-axis, right? Parallel, 0 degree. Okay, the field is gravity. Gravity is a field force. This require contact between two bodies. This work in a distance. There is no contact between moon and earth. Speaking of earth, let's make a planet called Need, which has a mass 6.5 times 10 raised to 23 kilogram. There is a asteroid 5 kilogram. Let's say small, very tiny, like a stone. The distance between these two, 5.5 times 10 raised to 6 meters. This guy has a radius. Radius is this one doesn't matter. The radius is 3 times 10 raised to 6 meters. Need force on asteroid by need is 7.15 Newton. The force on need by asteroid is also equal in magnitude, opposite in direction. Want to find the field. So to find the field, okay, so this is the field equation. So this is the field equation. You've seen it like a million times. To find the field, we're going to do it two ways. Number one, field is FG over M. So what is FG? 7.15. And what is M? 5. And this is Newton. This is kilogram. So Newton over kilogram. Also known as meter per second square. Also known as meter per second square. You can say 1.43 meter per second square. So this is field. There is another name for acceleration due to gravity is field. Do everything here. So Fg is equal to Fg. Right? We can definitely write that. Fg is equal to M. Oh wow, let's write M1G because the small mass doesn't matter. So this is, you can think of this is a planet Earth, and a 5 kilogram thing is a planet Earth, right? So, and this is distance away. So this is mass 1, and this is mass 2. Okay, so this mass doesn't really create its own gravitational field. This is not big enough to create gravitational field. However, this mass is big enough to create gravitational field, right? So this mass, when you drop an apple, right? Okay, apple doesn't create a gravitational field, right? So apple mass doesn't really matter. Okay, it doesn't contribute to anything. You can cancel it. In fact, it gets cancelled. Okay, so M1G is equal to G M1 M2 over R squared, and you see M1 M1 cancel. So field, we want to see whether this is Earth or any other planet, meaning that pretend like you don't know this is planet Need. Okay, G is 6.67 times 10 raised to negative 11. The mass of this unknown planet you just landed is 6.5 times 10 raised to 23 divided by the radius square, and the radius between the distance between these two bodies 5.5 times 10 raised to 6 square. So 6.67 times 6.5 divided by 5.5 squared times 10 raised to negative 11 plus 23 minus 12. So this is nothing, 1.43. So the field is 1.3 Newton over kilogram, which we already found it a different way. So that's the field.